All right, slope point form of the equation for a linear function. So just to quickly get started, we do need to review just a few little things about fractions. So when we add fractions, they need to have common denominators. When we multiply or divide, they do not need common denominators. So to simplify a, 3 over 4 plus 2, we need to turn 2 into a fraction with a denominator of 4. So if I want to put a 4 on the bottom, I need to also multiply the top by 4. So this will equal 3 over 4 plus 8 over 4, which ends up as 11 over 4. To multiply fractions, we do not need a common denominator. We multiply across the top, so it'll be 5 times 3 all over 4 times 4. This ends up being 15 over 16. So this graph shows the height of a candle as it burns. How would you write an equation to describe this line? Well, I have the y-intercept here, and it looks to be a nice whole number, and I could calculate slope. So I would use the variables from the axis here, and I would use the slope to use y equals mx plus b. Using these variables, I would actually use y as h, so it'll become h equals mt plus b. So b is 30, and the slope is rise over run, so down 10 and over 30. So negative 1 over 3 would be my slope. So I would write this equation as h equals negative 1/3 t plus 30. Suppose you could not identify the h-intercept here. How could you write an equation for the line? I'm not really sure. We need to get to this before we could attempt that. So the equation for slope point form is y minus y1 is equal to mx minus x1, where it passes through point P, which has coordinates of x1, y1. So these coordinates are going to be put into our equation. So x1 goes here, so there's going to be a number there, and y1, goes here. So we'll have a number there. What we'll be left with is a y and an x, and we will have a value of m, x1, and y1. All right, so how did this equation come about? Well, for this line segment, let's look at line segment PQ. We could say that the slope m is equal to, let's make point P 0.1 and Q 0.2. So remember, m is y2 minus y1 all over x2 minus x1. So we'll say our slope here, m, is equal to y, my mistake, y, because that is 0.2 coordinate, minus y1 all over x minus x1. What we're going to do is we're going to multiply both sides by x minus x1. So we're going to get x minus x1 times m, which equals y minus y1 all over x minus x1, all multiplied by x minus x1. X minus x1 cancels on this side, and we're going to be left with y minus y1 is equal to m x minus x1. So this entire formula here was just derived using slope. So describe the graph of the linear function with this equation. Well, remember the function equation is y minus y1 is equal to m x minus x1. So what we end up with, y To get a positive 1, this was take away, it must have been a negative 1, which equals, not m, but negative 1/2 x minus positive 2. So our slope was negative 1/2, and there was a point, which was 2, negative 1, using these two pieces of information here. So we can graph this equation, again, using our graph here. So 2, 4, 6, negative 2. All right, so plotting this, positive 2, negative 1 is here, and we'll use our slope down 1 over 2, down 1 over 2 to plot a bunch of lines, or points, sorry. We can also remember, say that slope is equal to 1 over negative 2. So we can go the opposite direction. We can go up 1 and backwards 2, up 1, backwards 2 to fill in the gaps and draw a nice straight line using a ruler through your graph. All right, write an equation in slope point form for this line. So pick any point on the graph. I'm going to pick this point here, point P. And the coordinates for this one is negative 2, positive 2. We will also need the slope, which is rise over run. And our slope is down 1 over 3. So this will be negative 1 over 3. Therefore, when we write our equation y minus y1 equals mx minus x1, let's just put in what we know. So y minus our point y is 2, which equals mx minus negative 2. So we should rewrite this as y minus 2 equals mx plus 2. Now, again, it doesn't matter which point you use for it. It will look different in this. Oh, I should have put my slope in, silly me. It will look different in slope point form. However, when we change it to slope intercept form, it will always work out to be the same equation. Okay, so ours may look different in this case, but they should look the same here if you've chosen a different point. So we're just going to rearrange. We want to get it to be y equals mx plus b. So we need y by itself. What I'm going to do first here, y minus 2 equals negative 1/3 x plus 2, is I'm going to expand my negative 1/3 into the brackets here. So we get y minus 2 equals negative 1/3 x minus 2/3. So we're going to move our 2 to the other side, so add 2 to both sides, and we get y is equal to negative 1/3 x minus 2/3 plus 2. We need to turn this 2 into a fraction to add it, so y equals negative 1/3 x minus 2/3 plus, now this is technically over 1, we need to make them 3, so we multiply both by 3, that'll be 6 over 3. Our very final equation is y equals negative 1/3 x plus 4 over 3. Okay, a temperature in degrees Celsius, C, is a linear function of the temperature in degrees Fahrenheit, F. The boiling point of water is 100 degrees Celsius and 212 Fahrenheit. The freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. Write a linear equation to represent this function. So because the temperature in degrees Celsius C is a linear function of the temperature in degrees Fahrenheit F, this says that F is the independent variable. It is what C is dependent on. Okay, so C is the dependent variable then. It's like it's acting as Y and Fahrenheit is acting as X. So we're going to use the coordinates here where they've given us the temperature in degrees Celsius and Fahrenheit, and we'll write them as a coordinate. Remember, coordinates are x, y. Therefore, our coordinates need to be written as Fahrenheit degrees Celsius. So Fahrenheit is 212, degrees Celsius was 100. Over here, Fahrenheit was 32, degrees Celsius was 0. So to write a linear equation, what we're going to do first is we are going to find the slope. y2 minus y1 all over x2 minus x1. And I'll label this is 0.1 and this is 0.2. So we'll get 0, take away 100, all over 32, take away 212. I get negative 100 all over negative 180, which we can reduce to a lowest common factor fraction of 5 over 9. So subbing into our y minus y1 equals mx minus x1, remembering that y in this case represented degrees Celsius. So Celsius minus Celsius 1 is equal to m Fahrenheit minus Fahrenheit 1. All right, so Celsius minus, let's just use 0.1 again here. 100 is equal to 5 over 9 Fahrenheit minus 212. Again, it doesn't matter whether you used our first or our second point here. Either or is fine. Now, it doesn't ask for a specific format, so I would just leave it here. That's easiest. Use the equation to determine the temperature in degrees Celsius at which iron melts. So we're going to solve for C given F. Let's sub into our equation. So C minus 100 is equal to 5 over 9 and 2,795 minus 212. So C minus 100 equals 5 over 9. I got 2,583 there. C minus 100 equals, multiplying those two together, I get 1435. Last step is to add 100 to both sides. C is equal to 1535, and that would be degrees Celsius. Write an equation for the line that passes through this point and is parallel to the line y equals 3x plus 5. When two lines are parallel, their slopes are equal. So the slope of this line is 3. Therefore, the slope of our parallel line will also be 3. Now, if we want to write its equation, we can say y minus y1 is equal to mx minus x1. So we'll put in our point. Y minus negative 3 is equal to 3x minus 2. Again, they have the same slope because they are parallel. Just finishing up here, y plus 3 is equal to 3x, oops, that should be a minus 2. All right, we want a line that is perpendicular to the line y equals 3x plus 5 and also goes through this point still. When two lines are perpendicular, their slopes are the negative reciprocal. So again, the slope of this line is 3, technically over 1. So the slope of our perpendicular line will be the negative reciprocal. So the reciprocal is 1 over 3 and make it the opposite sign. Again, subbing into our equation, we get y minus negative 3 is equal to negative 1/3 x minus 2. So we get left with y plus 3 is equal to negative 1/3 x minus 2. If you want, we can rearrange this into our slope intercept form just for some extra practice. So what I'm going to do first is I'm going to expand our slope into the bracket. So y plus 3 is equal to negative 1/3 x plus, because we have a negative 1/3 and a negative 2 here, 2/3. Then I'm going to take away 3 on both sides, and we're going to be left with y is equal to negative 1/3 x plus 2/3. Now minus 3 was technically over 1. We need to have the common denominator, so I'm going to multiply both by 3. So I'm going to be subtracting 9 over 3. Therefore, y is equal to negative 1/3 x minus 7 over 3.